Okay, good afternoon. Today we're going to be talking about properties of exponents. We are going to be talking about product of powers. We're going to be talking about quotient of powers. We're going to be talking about power of a power. And we are going to be talking about a negative exponent. So the first one that we're going to be discuss is that whenever you multiply a power and another power, so a product of a power, you're going to keep the same base and you're going to add the exponents. For example, if you have x to the third times x to the fourth, what you're going to do is you're going to keep the same base and you are going to add the exponents. You add the 3 plus the 4 and it gives you a 7. Another example would be if you have y to the fourth times y to the fifth, you are going to keep the same base, which is your y, and then you are going to add the powers. So you add 5 plus 4, which gives you 9. So what you do is all you do is add the exponents and keep the same base. For problem number 2, the quotient of a power, what we're going to do is anytime that you have a power divided by a power which has the same base, so for example, you have x, let's say a number 5, all divided by x to the third, what you're going to do is you're going to keep the same base of an x and you're going to subtract the exponents. You get 5 minus 3 and the answer is 2. If you have another one, x to the ninth, all divided by x to the third, you're going to keep the same base, x, and you're going to go ahead and subtract the exponents, and it gives you x to the sixth. So that is a quotient of powers where you have the same base, and all you do is subtract the exponents. The third power properties of exponents that we are going to deal with is, let me go ahead and clear the page, is a power raised to a power. So what you can do on this one is anytime that you have, let's say, x to the fourth raised to the fifth, what you're going to do is you have a power raised to a power, you have x to the fourth raised to the fifth, all you do is keep the same base and you're going to multiply the two powers, where you're going to have 4 times 5, which gives you 20. And that's your answer. If you have another problem like y to the third raised to the fifth, all you're going to do is keep the same base. You look at the power raised to a power, and you multiply 5 times 3, and the answer is going to be 15. So that is a power of a power. So that's a power raised to a power. So that is the third rule that we are going to be discussing. And our last rule that we are going to be discussing is, of course, dealing with negative exponents. Whenever we deal with negative exponents, we can never have a negative exponent. So what this rule tells us, if we look at it right here, is that we're going to multiply by the reciprocal. The reciprocal, so technically what they're doing is they're just throwing it down. So if the negative is on the top, it's in the numerator, you're going to throw it down to the denominator. If it's in the denominator, you are going to throw it up to the numerator. So let's say I'm given an x value of x to the negative 3. So by looking at that, you're going to rewrite it as it being 1 over x to the third. So all you're doing is flipping it and it becomes a positive. If you have y to the negative fourth, all you're going to do is flip it so it becomes 1y to the fourth. So that is a negative exponent, and I'm going to be teaching you how to do those negative exponents. So hopefully this will help you in regards to any time that you deal with exponents. So let's go ahead and get into some of the problems. So let me go ahead and get out of here. And then let me go ahead and pull out the exponents one. And you find it. Exponent practice. So we're going to look at some exponents. So the way I like to handle these type of problems, there are all sorts of problems. The way I like to handle them is I like to have a big division sign. So at the very end. So what I'm going to do is I have a green, I always like to put a huge division sign. That way I can work and keep on doing the work, and then I keep on simplifying it. So if you look at the top right here, the top is the numerator, and looking at that, you have a power raised to a power. So what I'm going to do is I'm going to multiply. I'm going to keep the same base of the x, and I'm going to multiply 5 times negative 3. And the answer is going to be negative 15. And then on the bottom, I'm going to have nothing there other than it being x to the negative 10. So just by looking at that, I have negative 15 and a negative 10. So what I like to do next is I like to put an equal sign and of course do the correct 10. I like to do lines like that so I can separate my work. So I have a power divided by a power with the same base. So the rule for this is to subtract the top number and the bottom number and keep the same base. So anytime that I have a pair, I always love to leave my pair on the top. Then of course, the difference between the negative and the negative, I don't like to deal with that. So I let Desmos do the work. So here I am, I'm going to clear my Desmos. And I'm going to say, well, what is x to the negative 15th divided by x to the negative 10th? I like to put my base on the top as an x. And I like to continue on with the division sign. So all I'm going to do is input it in Desmos right here. So I'm going to put negative 15 minus, and don't forget, it's minus negative 10. So I got to put a double negative as 10. So the answer of negative 15 minus 10, there's no work, there's no keep change, there's no none of that. The answer is negative 5. So I am going to have negative 5. But once again, we got to remember, we can never have a negative. So I'm going to do my work and I'm going to say, well, now I'm going to have to do with a negative exponent and I have to get rid of it. Well, how do I get rid of a negative exponent? I just throw it to the bottom. If it's in the numerator, I throw it to the bottom. Why? Because I'm multiplying by the reciprocal. And the easiest way is just to throw it to the bottom, throw it to the top. So right there, I'm going to have an imaginary 1. I'm going to throw the x to the bottom, so the answer is going to be x to the 5th as a positive. And that is our answer, simplified and ready to go. If we look at number 2, and you're looking at this, so the first step that we're going to do is, of course, do the huge division sign. We like to have the big division sign so we can do our work. I can do my line, or call it railroad tracks if I want to do the railroad tracks. Right there, I can do y to the 4 raised to the negative 5th, and as you can tell, it is a power raised to a power, so I am going to multiply. So I do y to the negative 20. And what happens if I don't know that that is y to the negative 20? I don't know what 4 times negative 5 is. Well, of course, I have decimals right here, my trusty decimals that I can just multiply 4 times negative 5. And I do 4 times negative 5, and that gives me a negative 20. Then on the bottom, I have the y. So I'm just going to leave it alone as y to the 6. Then I'm going to put my equal sign, and I'm going to go ahead and put another line, which is a railroad track. Now, I have a y on the top, I have y on the bottom. So what is that rule? We're going to subtract the two exponents. So we are going to keep a y at the top. I like to keep the y at the top. So what I'm going to do is I'm going to subtract negative 20 minus 6. And not just minus 6, because then that would be the correct, not the correct way to say it. I would say negative 20 minus negative 6. Well, I don't want to break my head over it. All I have to do is I input negative 20 minus negative 6. And is it okay to put parentheses? Of course it is, but I don't have to. It's not required on the Desmos. And then, of course, I have raised to the negative 14. But once again, I am not done. I have one more step. So I'm going to put an equal sign. I'm going to do my line. And if I look at the top of the division sign, how do I get rid of the negative? I'm going to throw it to the bottom, and I'm going to put y is equal to positive 14. And of course, on the top, it's an imaginary 1. So that is our answer, 1 divided by y to the 14th. If we look at number 3 is the same thing. So we are getting practice with our Desmos. So we're going to do the same concept. We have the power raised to a power at the very top. So I'm going to put in an equal sign. I'm going to do the long division sign. I'm going to go ahead and put my line. And I'm going to say a 2 times negative 4 is negative 8. And then I have a to the negative 6. I did nothing to it. I put an equal sign. Then I divide it with my railroad tracks if I want to. And right there I have an exponent, and I have the same base. So what I like to do is I like to put the a at the top. And once again, if you don't know how to multiply negative 4 times 2 to get a negative 8, all you have to do is input it into your Desmos. So right here we have a negative 8 minus a negative 6. So I don't like to think because there's too many negatives. Sometimes we have too many negatives, so I just input it and let the Desmos do the work for us. So I input negative 8, and then I'm going to subtract negative 6. And of course, do not forget to put the double negative. And the answer is a to the negative 2. And then I'm going to put an equal sign. Why am I going to put an equal sign? Because, of course, I can never have a negative. So I want to change the negative to a positive. So what I do is I throw it down to the bottom of the division sign. So a to the second is going to be on the bottom. And, of course, our imaginary 1 or semi 1 is going to be at the top. And that is my answer. 1 divided by a to the second. By looking at problem number 4. I'm doing the same type of problem, so I'm going to put an equal sign, and of course I'm going to do my long division sign all the way to the bottom, and then I'm going to do my railroad tracks. Next, on the top of the numerator, I have a power raised to a power, so then that gives me b 4 times 3, which gives me 12, even if I don't know how to do 12. 4 times 3, I can also put it in Desmos. All I have to do is input 4 times 3, and that gives me 12. And then on the bottom, I'm just going to leave it alone, negative 5. Then I'm going to put equals 2, and then I'm going to do the line like that. So I have the row of division, so I'm going to put the base of b at the top. And then I'm going to subtract the two exponents. So the way I have to input it in Desmos is going to be 12 minus negative 5. So I'm going to input that in Desmos, 12 minus negative 5. So that gives me a positive 17. Now, if I look at that, oh, now it's positive. I don't have to throw it to the bottom anymore. It's a positive. So that is my answer. So I can write b over 17 over 1, or I can just put b to the 17th. If we look at number 5, now we're going to be dealing with a little bit more complications. So now I have a bigger problem to deal with. So I have 45 divided by 15, and then I have m to the negative 5 divided by m to the negative 3. Then I have p to the 4th divided by p to the 6th, and b to the 16th divided by b to the negative 5. So I have a problem, a problem, a problem, and a problem. So what I like to do, and since I have very little space here, I'm going to go ahead and put the big division sign down here. So the first step of this complicated problem, it really isn't complicated, but it's really looking at this part of the problem, which is 45 divided by 15. And I don't know what 45 divided by 15 is. Well, let me go ahead and put it in Desmos, and let me see what Desmos will tell us. Well, I'm just going to put 45 divided by 15. And of course, Desmos does the work for us. It comes out to 3. So all I have to do is put the 3 there. Then I check to see that I have a pair of m's and a pair of m's. So if I look at the pair of m, I'm just going to write pair of m's. And then what I'm going to do next is I'm going to subtract a -5 minus a -3. So what I'm going to do is I'm going to input it in decimals because I don't want to really work hard. I want to work smart. So I have -5 minus a -3. And then that gives me a -2. So that is the top part. Then I have a pair of p's. I'm going to go ahead and put a p up there. And then, of course, the rule when I subtract integers and I have a division, I'm going to subtract the little exponents. So then all I'm going to do is go 4 minus 6, and then that gives me a -2 on top of the p. And then the v, I'm going to do the 16 minus a -5. So what I'm going to do is I'm going to do 16 minus -5, and that gives me a +21. Then I'm going to put my equal sign, and then I'm going to do my railroad track so I can separate, and now it becomes easy. The 3, of course, is positive. It's going to stay up there, and of course a 3 would stay up there. Now, looking at the p to the -2, I want to change it into positive, so I'm going to write it positive, but I'm going to throw it to the bottom. It's in the numerator. I'm going to throw it to the bottom, and it's going to become positive. If I look at the p to the -2, I'm going to throw it to the bottom, and it's going to become positive, and nothing's going to happen to v to the 21st. I'm just going to leave it alone, and that is my answer. I can go ahead and circle it, and that right there is my simplified answer. So let's do another one of these examples. As number 6, it looks complicated, but it really isn't because a lot of the work can be done by our decimals calculator. So I'm going to do the big division sign, of course, like I always do. I sometimes like to do that line, so then that way I can go ahead and see, okay, what am I going to do? Look at that fraction I have, 60 over 10, or 60 divided by 10. And I don't know what 60 divided by 10 is. Not to fear, decimals is here to give us our fraction. So 60 divided by 10 is going to give us 6. So I am going to put a 6 at the very top right here. Because 60 divided by 10 right here is 6. Then I have a power, and I have another power. I'm dividing the power. So I am going to go ahead and put an x there. I got a 4 and I have a 6. So what I do when I divide exponents, what I'm going to do with the same base is all I'm going to do is subtract them. So it's going to be 4 minus 6. And the answer is -2. So I put 6x to a -2. Now I go to the y's. Do I have a y on the top, a y on the bottom? I do. I'm going to go ahead and put a y right there. And then all I do is subtract it. It looks hard, but it really isn't. You subtract -6 minus -8. So I'm going to do -6 minus -8, which is a -8, which gives me a +2. And no work required on that because it would have been -6 plus minus, and of course, well, not plus minus, it would have been plus plus, and that would have been a positive. But again, once again, decimals does the work for us. Then I have a pair of z's, and I'm going to put a pair of I'm going to put a z there. So what I'm going to do is I'm going to subtract 10 minus 8. Well, I don't know what 10 minus 8 is. All I do is place it on the decimals calculator, and I'm going to do that. And then I'm going to subtract it, and it gives me 2. And then I'm going to put my equal sign, and then I'm going to go ahead and put my railroads going down. So I'm going to change the color, and I'm going to put my railroads down. Then 6 is good being on top. He likes being on top. Leave him on the top. Then I have x to the -2. I cannot have a negative exponent, so I got to throw him to the bottom, and he becomes a +2. Then I have y to the second. It is a positive exponent, so there's nothing I have to do with it. So I leave him in the top. He likes being at the top, and he likes being happy on the numerator. So leave him alone. He is very happy being positive. Then after that, you're going to put z to the +2. So the correct answer is we have everything as a positive. So we have 6y to the second, z to the second, all raised divided by x to the second. And this is your correct answer. So going on problem number 6, we're going to go to problem number 7, and we have another one that we've done. So looking at that, I'm going to put the big division sign on the bottom. First step I'm going to do is I'm going to do this part, the 80 divided by 20. And if I don't know how many times 20 goes into 80, not to fear, Desmos is here to give you the answer. So 80 divided by 20, going to input it, and the answer is 4. That is going to be at the very top, right there, 4. Next we have an A and an A, so I'm going to put an A right there. And what I'm going to do is I'm going to subtract the exponents because I'm dividing with the same base. So I'm going to put it into Desmos, and I'm going to go ahead and put Desmos right here. I'm going to get my keypad right here, back up, and then it's going to be 2 minus 6. And 2 minus 6 is a negative 4, so I have a negative 4 right there. And then I have the B's. I have a pair of B's. I'm going to put the B right there. All I have to do is put it on Desmos. And I'm going to put negative 4 exactly the way it is. Negative 4 minus negative 5, double negative, which gives me a positive 1. And then, of course, I have a pair of C's. I'm going to keep the C there. And then I'm going to subtract the exponents, 9 minus 5. 9 minus 5, if you look at it, it's going to be 9 minus 5 is going to be 4. So I have 4 raised to the A to the negative 4, B to the 1, and C to the 4. But bad, we cannot have a negative 4. So I'm going to go ahead and put an equal sign here. And then I'm going to go ahead and draw a railroad track so I can separate it. On the top, nothing's going on with the 4. I'm going to leave him on the top of the numerator. Then I don't like that A to the negative 4. I cannot have an A to the negative 4, so I'm going to multiply by the reciprocal. But the easiest thing is just to throw it down to the denominator. It becomes positive. And then B to the 1 power, I'm going to leave him alone. He's going to stay at the top, and C to the 4th is the same thing as C to the 4th right there. So I have all my exponents positive, so then that way, that is my answer. So looking at that, it looks complicated at first, but it really is not complicated. So I'm going to be going to my next one. And my last one that I am going to do for today is, of course, this one. So just by looking at that, I can already see that there's pair, a pair, a pair, and a pair. So what I'm going to do is I'm going to go ahead and put it in blue, and I'm going to circle this. Next step is I'm going to do the division sign, the big division sign. And then I don't know what 75 divided by 15 is. Not to fear, Desmos is here. All I'm going to do is put 75 divided by 15. Put in Desmos, the answer is 5. I'm going to put a 5 at the very top. Then I have a pair of m's and I'm dividing. So what I'm going to do is I'm going to subtract the two exponents. So all I have to do is place it in the Desmos. And I'm going to put negative 6 minus negative 4. I'm going to go ahead and input it into the Desmos. Negative 6 minus negative 4. Let the Desmos do the work. And it's m to the negative 2. Then I got a pair of B's, and it is 6 minus 9. So what I'm going to do is I'm going to do 6 minus 9. And the answer is P. I'm going to put the P, and I'm going to do negative 3. I'm going to have a lot of negatives. And then the B, I'm going to keep the pair of B's right there. And I'm just going to subtract the exponents. So I'm going to go ahead and subtract 10 minus negative 6. And the answer is 16. So what I'm going to do is I'm going to put the equal sign. I'm going to go ahead and divide it so I can divide my work. Nothing's going on with the 5. 5 likes being alone. So he's going to be just put right there. Then the m to the negative 2, there's an issue with m to the negative 2 because we cannot have a negative exponent. So how do I get rid of m to the negative 2? I throw it to the denominator and it becomes positive because technically you are multiplying by the reciprocal. If you have p raised to the negative 3, I don't want it negative, so I just throw him to the bottom and he becomes to the positive 3. And v to the 16th, there's nothing going on with v to the 16th. I'm going to leave him alone, and I'm going to keep it at the very top. So that is my answer, 5b to the 16th, m to the 2nd, and p to the 3rd. So what I have just discussed with you is an introduction to exponents, adding, subtracting, multiplying, and dividing exponents. I hope this has helped you in your journey to learn exponents. Once again, if you need anything from me, do not hesitate to reach out to me. Have an amazing day, and if you need anything, don't hesitate to let me know. Thank you.